So, this is chapter 3. In this chapter, we're going to talk about several things. One, we'll look at different types of claims that you can base on a study, right? As the title says, we'll look at 3 different types of claims based on frequency, based on association, and based on causality, to run ahead of things. We'll look at different types of validities. How real or plausible are these findings and the conclusions that can be drawn from them? How real or plausible they are, scientists call validity. So we're going to look at 4 different types of validity. Now, it's important to remind you that everything you learn, or pretty much everything you learn in this course, sort of builds on what you learned earlier. These different claims and these different validities are going to be relevant for the rest of this course. So you need to understand this stuff, not just for the rest of this course, but for many of you, for the rest of your career. So first thing that we need to talk about are variables, right? All claims in psychology and other sciences for that matter are about variables. What's a variable? A variable is something that varies. You could have figured it out yourself. Yeah, a variable, as the word implies, is something that varies. So it must have at least 2 levels or values. Some variables have 2 values, some 3, some can take a whole lot of different values. Okay, biological sex, if we ignore various intersex conditions, the vast majority of us, biological sex has 1 of 2 values or levels, male and female. Okay. The number of eggs a chicken lays each day is also a variable, and depending on how many chickens you have, it can be 0 or 1 or 2 or I guess 3 sometimes. I don't know how many eggs chickens lay, right? But those can be the possible values. If you have cows, or if a farmer has cows, then the amount of milk a cow yields each day in gallons can be one of any number, right? So variables are things that vary. When we're talking about a given study, a variable is something that varies in the context of that study. If something doesn't vary in the context of that study, we call it a constant. Now, back to my old examples, right? You walk into a room, you see a switch, and you see a light bulb. What do you do to see if the switch controls the light bulb? You flip it. So we have 2 variables in play in this situation. One is the position of the switch, which can be up or down, and one is whether the light bulb is on or off. 2 variables, and we want to see if there's an association between those 2. Okay. Whether or not there's a door in this example is a constant. My other example was in a imaginary study of a drug that's supposed to increase appetite, right? We have 2 groups of rats. Each rat in one group receives an injection of, let's say, 100 milligrams of this drug. The other group receives an injection with a placebo. And then we measure for each rat in both of these groups how much they eat, how many pellets of rat chow each rat eats. And if our drug works, then we expect that the group of rats that received the drug will on average eat more than the rats that did not, right? So once again, we have 2 variables. And the one variable is how much many pellets of rat chow each rat eats. The other variable is, no, not just the drug. The other variable is whether or not a given rat receives the drug. Right? That's what varies between the rats. Or, phrased differently, the dose. Right? 100 milligrams versus 0 milligrams. Yeah, sorry to keep giving silly examples, but I do think that silly, simple examples can help you understand things. Right? So a variable in the context of a study is something that varies, as opposed to a constant, which is something in a study that doesn't vary. Another example of a constant is in claims such as 15% of Americans smoke. I don't know if it's actually 15% or not. That's not relevant. But in the claim 15% of Americans smoke, one variable is whether or not an individual smokes. But nationality is not a variable, it's a constant, right? In our claim, nationality doesn't vary. So nationality, we're only talking about Americans in that claim, so nationality in that claim is a constant. Another very important thing to emphasize is the difference between what we call a measured variable, or sometimes an observed variable, and what we call a manipulated variable. Example, if I wanted to know your height, I would measure it, right, with one of those measuring tapes or something like that. I would measure it. If I wanted to know your shoe size, I could also measure it or look at the number on your shoe. If I wanted to know your IQ, I could measure it. If I wanted to know whether or not you're an introvert or an extrovert, I could administer a personality questionnaire. Right? Measured variables we measure with certain tools. Other variables, like perhaps biological sex, we can observe. That's kind of also like measuring, right? At least for most people, we can observe that. Or even if we, a better way, of course, to do it is to ask people how they identify. That's still kind of a form of measuring or observing, right? Or hair color, we can observe that. As opposed to a manipulated variable, the value for each participant is determined by the experiment. Example is, go back to our rat study, right? The experimenter determines whether each rat will get an injection of the drug or of the placebo. So that is called a manipulated variable. That's called manipulation when the researcher, him or herself, decides for each individual what the value is going to be. So if we go back to the light bulb example, you're the one who flips the light switch. So the light switch being up or down is a manipulated variable. Giving a variable different values yourself is called manipulation. I understand that manipulation has a lot of different meanings in everyday speech, but in the context of a study, it means when the researchers themselves create these different values for a given value. Okay, so in this case, you're the person who's flipping the switch up or down. You're the one who manipulates the switch. You're the one who manipulates that variable. Then you observe whether the light is on or off. So whether the light's on or off is then a measured variable. In the rat study, again, to go back to the rat study, right? Each rat receives an injection of either the drug or a placebo that's determined by the experiments. Right? So whether the rat receives a drug or a placebo, or the dose in other words, is a manipulated variable. Then for each rat, we measure how much they eat. So how much they eat would then be a measured variable. Some variables can't be manipulated, right? Like biological sex, right? That's just a natural given. A researcher, him or herself, can't say, in this study you're going to be male and you're going to be female. It doesn't work like that. Or age, right? We can't randomly assign participants to the 4-year-olds or 5-year-old group. Age is just a given for each person. We can't assign these values. We need to observe or measure them, but they can't be manipulated. The same goes for IQ, or various measures of your personality, or perhaps your chosen major. There's a variable that for most people can't really be manipulated, right? You've chosen that. The experimenter doesn't get to decide that. Sometimes a variable can be either, depending on how we choose to study it. Right? If we wanted to look at, some measure of health and sugar consumption, what we could do is measure sugar consumption, for instance, by asking people how much sugar they eat. And then it would be a measured variable. But we can also, if participants agree to that, put them on a high sugar or low sugar diet, in which case sugar consumption would be a manipulated variable. For some variables, they theoretically could be a manipulated variable, but we can't do it because of ethical reasons. For instance, trauma, right? We could traumatize one group of children and not traumatize another group of children, but that would be grossly unethical. What we could do is compare people who've suffered trauma versus people who don't, in which case trauma would be a measured variable, but it can't be a manipulated variable. Although we could perhaps, although some of you might object, but we could do it perhaps in animals, right? We could randomly expose one group of rats to an extremely fearful event and the other group not. Or let's say another example would be the type of math instruction, right? If we wanted to compare one type of math instruction versus another type of math instruction, what we could do is go to different classrooms where we have a group of kids who are already taking that one group of math instruction and go to a different classroom where the kids are already taking the other type of math instruction and compare those two. In that case, it would be a measured variable. But we could also, perhaps in a different study, take a group of children who are about to undergo math instruction and randomly assign each kid to either one or the other type of math instruction, and in that case it would be a manipulated variable. Point being, some variables can be measured only, some variables need to be manipulated. Sometimes they can be either, depending on the type of study that you're doing. Side note, it's kind of interesting to consider that some things can be manipulated nowadays that we weren't able to do in the past. For instance, in this day and age of genetic engineering with experimental animals, we could genetically engineer one group of rats to have a certain gene, genetically engineer another group of rats to not have that gene, and then, do something and then compare them, right? In the past, before genetic engineering, this wouldn't have been possible, and the presence of a gene would just be a measured variable. But sometimes, at least in experimental animals, it can be a manipulated variable. Obviously, for ethical reasons, we can't manipulate genes in human beings.